Hello, welcome to Learning Box. Today's discussing topic is decision tree classification algorithm. Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. It is a tree-structured classifier where internal nodes represent the features of a dataset, branches represent the decision rules, and each leaf node represents the outcome. In a decision tree, there are two nodes, which are the decision node and leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain further branches. The decisions or the test are performed on the basis of features of the given dataset. It is a graphical representation for getting all the possible solutions to a problem/decision based on given conditions. It is called a decision tree because, similar to a tree, it starts with the root node, which ends on further branches and constructs a tree-like structure. In order to build a tree, we use the CART algorithm, which stands for Classification and Regression Tree Algorithm. A decision tree simply asks a question, and based on the answer yes or no, it further split the tree into subtrees. Below diagram is the general structure of a decision tree. Note, a decision tree can contain categorical data as well as numeric data. Again, that is end with yes or no. Why use decision trees? There are various algorithms in machine learning, so choosing the best algorithm for the given dataset and problem is important to remember while creating a machine learning model. Below are the two reasons for using the decision tree. Decision trees usually mimic human thinking ability while making a decision, so it is easy to understand. The logic behind the decision tree can be easily understood because it shows a tree-like structure. Decision tree terminologies. Splitting. Splitting is the process of dividing the decision node/root node into subnodes according to the given conditions. Branch/subtree, a tree formed by splitting the tree. Pruning. Pruning is the process of removing the unwanted branches from the tree. Root node is from where the decision tree starts. It represents the entire dataset, which further gets divided into two or more homogeneous sets. Parent. The root node of the tree is called the parent node. Child node. The parent node of the tree is called the child node. Leaf node. Leaf nodes are the final output node. Tree cannot be segregated further after getting a leaf node. Practical example in decision trees. First part is installing requirements. Install requirements by using pip in CMD. Use pip install scikit-learn to install scikit-learning library. Moving to next. Data requirements. First thing is, problem statement. Let's assume we want to play badminton on a particular day, say Saturday. How will you decide whether to play or not? Let's say you go out and check if it's hot or cold, check the speed of the wind and humidity, how the weather is, i.e. is it sunny, cloudy, or you take all these factors into account to decide if you want to play or not. So, you calculate all these factors for the last 10 days and form a lookup table like the one here. Now, you may use this table to decide whether to play or not. But, what if the weather pattern on Saturday does not match with rows in the table? This may be a problem. A decision tree would be a great way to represent data like this, because it takes into account all the possible paths that can lead to the final decision. Data available and as follows. Weather sunny, temperature hot, humidity high, wind weak and expected no means not to play. Weather cloudy, temperature hot, humidity high, wind weak and expected yes means to play. And so on. Hope you understand the problem statement and the data. Data preprocessing. Convert input table data into labeled data. Use sunny. 1. Cloudy. 2. Rainy. 3. Similarly, output yes is 1, output no is 0. And apply same to other columns. Use any preprocessing methods as link given this description box. Note, data minimal and fitting to ideal case. For real model need more data to train. Lastly, ML model. With labeled data X, Y as train data, X is train input and Y is train output. Open any editor or Jupyter notebook, and then import Decision Tree Classifier class from scikit-learn library. Create Decision Tree Classifier instance or model by Decision Tree Class as DT. Then fit the input X and output Y to instance or model. Finally, check the score, ideal it should be 1. If data has no confusion. Time to test the DT model, calling predict function with cloudy as 2, hot as 1, normal as 2, weak as 1. Got output as expected 1, means yes or today we can play. Hope this discussion helping to decision tree implementation. Disadvantages of decision trees. Decision tree learners can create overcomplex trees that do not generalize the data well. This is called overfitting. Mechanisms such as pruning, setting the minimum number of samples required at a leaf node, or setting the maximum depth of the tree are necessary to avoid this problem. Decision trees can be unstable because small variations in the data might result in a completely different tree being generated. This problem is mitigated by using decision trees within an ensemble. There are concepts that are hard to learn because decision trees do not express them easily, such as XOR, parity, or multiplexer problems. Predictions of decision trees are neither smooth nor continuous, but piecewise constant approximations makes model failure. Therefore, they are not good at extrapolation.
Enjoy machine learning.